This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking windsite owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the Uptime Podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett. I'm joined here today by Alan Hall. No Rosemary Barnes today on the show. She couldn't make it with her crazy Australian time zone. We love having her on the show, but sometimes, you know, those 13-hour differences will get you. But look for her back on the show next week. But today we have an amazing guest. Today we are talking with Chris Howell from Veolia. He is the Senior Director of Recycling Operations there. He's also a Navy veteran, a graduate of the Navy Nuclear Program, is a subject matter expert on mining, metals, and power production. And he's been with Veolia for 27 years, so he knows that company inside and out. And we're going to be talking to him today about about their partnership with GE on shredding and recycling wind turbine blades into cement. So, Alan, what were some of your takeaways from today's talk with Chris Howell?
Well, Chris and Veolia have taken on a really large problem, which is as wind turbines become decommissioned, what do you do with those massive blades? Currently, we are burying them in some parts of the world, like in Germany, the burying of blades is outlawed. So we need to find another solution in the United States and across the world. And Chris and Veolia have stepped up to find a method, an economical method, to take those existing blades off the turbines, break them down, grind them up, and recycle them, reuse them for energy production or creation of cement, which is just totally fascinating and a really unique engineering exercise. So this interview, from an engineering standpoint, is really cool.
Yeah, and it's one of those things where on the web, in the public, in the media, people are just like, yeah, recycle these things, and they just wash their hands of it, right? But it's really, really complicated. That's part of the reason everyone's trying to do more and more manufacturing on site at new wind farms. That's why they're trying to do, to pretty much stand up an entire wind turbine on site, because it's so hard to transport these huge blades. And that could be at the beginning of its life or at the very end. So, this idea of just recycle them. Well, we got to put them on a flatbed, and that's not easy. And we've got to truck them X amount of miles to a processing plant. That's not easy. There's just a lot of challenges that he talks through, and they've done a pretty good job about solving a lot of those. They go through a multi-layered sort of process of shredding, so they can get that gigantic blade into smaller chunks and then into a first shred, where it's then that raw material is going into a semi instead of on a flatbed. So they've thought through a lot of the logistical headaches, which again make this a much more complicated problem than one would think just on the surface.
Yeah, it's a tremendously complex problem, and it's one of those problems that can only be dealt with by a large organization that has the mass and the cash and the infrastructure to tackle a problem that large. And we haven't really seen it out of some of the usual suspects. So it's interesting that Veolia stepped into that role with GE, by the way. And GE has taken an active participation in this, in the sense that they're working with Veolia. They're also helping them look at the whole CO2 chain involved in recycling to make sure that is Veolia's approach the most efficient, and is it taking the account of all the different CO2 uses throughout the recycling chain, which is very beneficial to Veolia to have someone as knowledgeable as GE at the table too. So you got two really knowledgeable companies with a pile of very smart engineers working together to solve a problem. That's that's really good to see. As an engineer, I like seeing engineers work together to tackle large problems. And this is a very large problem that's only going to get bigger unless we do the work now. And Veolia's taken on that challenge.
Yeah, I mean, the piece that you just mentioned about, only a big company can tackle problems like this, and we're only talking about wind turbine blades that are 20 years old, the ones that are getting decommissioned now. These are way smaller, as we'll talk about with Mr. Howell, way smaller than the ones that are rolling off the factory line today. So like the technology, the saws and the grinders, the shredders to take down some of these blades on a Halley 8X, for example, those don't even exist yet. They're going to have to continue to get better and to develop new shredders with all these different partner companies. And this is just the beginning. It's very far from the end, but what they're doing is pretty interesting. I think they're almost at 90% recyclability right now, and they're going to jump to hopefully 95% by next year, he said. So pretty exciting stuff for the industry as a whole, because this was something that got a lot of bad PR just a year ago, showing those photos of stacks of huge blades just in landfills. I mean, that's not good for anybody. And like you said, they've really stepped up to tackle this problem. So before we get going, I want to remind you, in the show notes of today's podcast, not only will you be able to follow with Veolia, but you'll also be able to sign up for our weekly newsletter, Uptime Tech News. So you'll get notified as soon as a new podcast episode like this one drops. So if you're interested in all of our podcasts, which, thank you for listening. We appreciate our audience quite a bit. Definitely sign up and you'll get notified. Hey, here's the new podcast. Here's what's going on. And here's some good stock news and other wind energy tech news from around the web. So again, you can not only follow up with Veolia and our guest Chris after the show, but also sign up for Uptime Tech News. So without further ado, we're going to jump to our conversation with Chris Howell, Senior Director, Recycling Operations at Veolia. All right. Well, Chris, thanks so much for joining us. We're excited to talk to you here today about all these recycling initiatives you guys have over there at Veolia.
Well, thanks for having me, Dan. Appreciate it.
Yeah, so we want to get kicked off. It's kind of talking about GE. So obviously you guys have been in the news a bunch. GE's off to a great start with, the Biden administration, all the renewable stuff that, the United States is hoping to push. So this is a really exciting time. But it looks like, GE had a problem that they've realized, as many other OEMs have, that there's just an alarming number of blades ready to get decommissioned, go offline. And, there was some really bad PR showing some of these gigantic blades in landfills, right? And so the uproar, I think, was warranted. People don't want to see these in landfills. And I know you guys at Veolia and GE don't either. So can you tell us a little bit about the partnership with GE and how you guys stepped up to start to turn some of these blades into concrete?
This journey began several years ago. And previously, I worked directly with Veolia in France as a member of the corporate staff and helped manage our global mining metals and power business. And on the power side of things, Europe has been much more mature with renewable energy, perhaps than the US has. So assets in Europe have reached their traditional end of life quicker than we're seeing those in other locales, especially the United States. So Veolia has been looking at circular economy solutions for renewable energy for quite some time. For instance, we have a PV solar panel recycling facility in France and have had for several years. So several years ago, we started looking. The industry came to Veolia and asked if we had solutions specifically for the wind turbine blades. And we went on a journey and looked at a number of different technologies and put those through the process at Veolia for validation. And the really long story short there is traditional recycling technologies at this time and at that time didn't really make sense from an economic standpoint. It took $20 worth of effort in order to produce $3 worth of material that really didn't have a considerable appetite for the offtake of that material. And that was Europe. Europe also had some other challenges just with the ability for material to cross borders and go border to border. And each country kind of had their own regulations on how they managed materials. For instance, in Germany, it's illegal to landfill a wind turbine blade, but it's legal in France and in Spain. So it was becoming rather challenging to find a solution in Europe. And about the same time, GE Renewables approached us first in Europe as part of that dialogue. And then they said, hey, how about the US? And we asked, well, what about the US? Well, in the US, we're doing this thing called repower. And repower is a movement to take assets and upgrade them from an efficiency standpoint, use the same mast or pole, retrofit new technology on top of that pole, and realize a 15 to 20% improvement in efficiencies, and also at a lower cost. In the last decade or so, the cost of the technology has come down considerably. So there's quite a motivation in the US to repower existing assets. And part of that repowering is also to continue to receive a production tax credit associated with that. So certainly the optic associated with renewable energy, regardless of its type, going to landfills is really not something anyone wants to see. It's a more environmentally sustainable way to generate electricity, so there needed to be a more environmentally sustainable way to manage end of life for those assets. And as a result of a legacy of business that Veolia has done globally, as it manages different types of waste throughout the world, in the US in particular, we utilize cement kilns as an outlet for engineered fuels. And so specifically our management of medical waste, or some types of medical waste, were being shredded and being blended and being used as an engineered fuel in cement kilns. So we looked at, we compared those types of materials with the wind turbine blade material and saw that it was rather similar in its makeup. It's got a BTU value associated with it. It's a non-hazardous material. Might this be something that cement kilns might want to utilize? And so the blades aren't used in cement. They're actually used as part of an engineered fuel and a raw material displacement in the production of cement. Cement being the powdered material that you would see typically, in concrete being the material you'd pour for sidewalks, roads, bridges, etc. So it's quite a unique production method to make cement. It takes heat energy, it takes raw materials, it takes different chemistries in order to make different mixes of cement. And it just so happens that utilizing this material as an engineered fuel, or what we call repurposed engineered materials, or REM, for cement co-processing worked very, very well and continues to work well.
So Chris, what's the breakdown of these, the content of a blade? So I read that resin is about 28% or so. Is that right? What's the full breakdown here that we're looking at?
So every blade is uniquely different depending upon who manufactures it. But they're predominantly made of fiberglass, certainly resins. Balsa wood is used as part of the construction method. There is some non-metallic metal components in the blade itself, not very much. And there's some other materials like chlorinated foams and things of that nature. So the blades that we are seeing currently as a result of repower typically weigh 6 to 7 tons each. Each one of those blades can displace the use of coal. In a cement kiln, on the order of about 5 tons of coal can be displaced. Nearly 3 tons of silica gets displaced, and nearly 2 tons of limestone can also be displaced. Again, depending on the specific makeup of the blade. But in general, there's quite an amount of energy that can be utilized from the blade itself, and there's quite a bit of raw material that can be displaced. In addition to that, there's a CO2 offset capability. Somewhere between 25 to 28% of the materials identified in a wind turbine blade are biogenic, which means they're non-greenhouse gas forming. So there's a benefit, a decarbonation benefit with using this material as a heat source for the production of cement.
Yeah, that's really interesting, because in one of our previous episodes, we were just talking about thermoplastic blades and whether they might have a future commercially, which is probably, a good amount of years off. But one of the things that Rosemary, our other host of the show, was talking about is that once you cure these resin systems, they can't be melted down again, right? They're permanently only a burnable material after they've cured. And I think that's one of the things that the public doesn't quite understand about the difference between plastics and resins. Alan, did I get that right?
Yeah, for the most part. So the thermoset resins, epoxies that we get at the hardware store or a different kind of chemistry than what we're now contemplating for blades, which is a plastic material, which can be extruded and recycled over and over again. But for the vast majority of wind turbine blades that are out in service today are a thermoset, epoxy, polyester type of thermoset, structural epoxy.
And Alan brings up a great point. And the point is that there's an existing inventory of material out there that's been out there for quite some time that represents tens of thousands of blades globally. The wind industry is definitely looking at initiatives to come up with alternative materials that are more recyclable, that are more in tune with circular economy. And there is a significant amount of effort being put in by all manner of different OEMs and other members of the wind turbine community in order to come up with better recycling capability for end of life.
Yeah, and that's really interesting to think that, essentially these wind turbine blades are fuel, like a portion of them. Like, you wouldn't ever think of it that way. You think of it just as waste, but really you can break it down, like you said, and like we're going to get a certain amount of BTUs of heat when we burn this blade after we've shredded up and all that stuff. So that's pretty amazing. So Chris, I want to ask you, obviously Veolia is a big company. You guys did $40 billion in revenue in this past year. You have 300,000 employees. Like, you're a multinational. How fast can you stay with the evolving technology and like the pileup of blades? I mean, is it really difficult to be innovative and move as fast as you might want to help protect the environment within such a large company?
Well, certainly being a large company has its advantages and disadvantages. And certainly it can be tough to get the ship to move sometimes when you need to change course and direction. But Veolia is firmly committed to an ecological transformation. That's what we do. We consider ourselves resourcers, and circular economy is a big part of that. What our initiative is and what Veolia promotes internally is we're actually a startup within the greater company of Veolia. So we were given the resources, both in human resources and intellect, and certainly revenue, in order to develop what we thought was going to be a good solution. Veolia is able to allow those types of innovations to be done on a localized effort, so that we can be what we call global. We can be global, but we're leveraging the local expertise that we have in different business units throughout the world, in many different offerings that Veolia would have, whether it be wind turbine blades, PV solar panels, different aspects of water, energy, you name it. To have all of that just centered in one location kind of defeats the purpose. So we do have the freedom, if you will, if we've got a good idea that makes commercial and technical sense, to be able to promote that innovation, invest in it, and then to launch it into the marketplace. And that's exactly what we've been able to do so far with what we're doing.
And I'm sure with new products, and obviously wind turbine blades have been around for a long time, but as everyone just starts to tackle this problem of how do we recycle them, how much research and development? I mean, there's got to be a long period of time before any of this starts to pay off. Where I'm sure you're looking many years ahead, where it's like, okay, if we start to allocate a team, good engineers, good people, some financial resources, what does that process look like as you guys start to, like you said, tackle some of these new problems?
Well, the benefit that we have at Veolia is we're over 160 years old, and as you mentioned, several 100,000 employees. So I'd love to say that our team came up with this idea solely on its own, but it didn't. We were able to leverage past experience within Veolia. Someone was smart enough to say, hey, that sounds like something we might be able to provide a solution for. And that starts the dialogue. It starts a dialogue internally. From the longest thing to do to bring this to market was actually to negotiate the commercial contracts that we've got. From the time of go until the time we were processing blades was a little less than a year, which, given that it took place during the pandemic, is pretty extraordinary just by itself. So, there's no I in team. I know it's a cliche, but it was definitely been a team effort here, and the team spans the globe. We're lucky enough to have a network of communication that allows us to leverage expertise from different people in different cultures and geographies, and really drive the diversity of technology available that we've got globally.
Yeah, Chris, I want to just talk about just Veolia a little bit. And having gone to your company website, I was really impressed about the emphasis that Veolia has on basically maintaining the earth and doing some of the difficult things that it take to keep it clean. And I think that's one of the benefits of having a large company is you can tackle those larger problems, like the wind turbine recycling problem. How many people globally were involved in the recycling of wind turbine blades? Did you have, was it mostly focused in the United States, or is it over in Europe too? Are they working together? How did it all get pieced together as a team?
Sure. So I was fortunate that I was part of corporate Veolia. So I had the vision, the visibility of the number of different aspects within corporate in order to be able to leverage and get this moving quickly. Again, the hardest convincing was on the commercial side. Veolia is a for-profit company. Build it and they will come is not necessarily the best business strategy. So, convincing leadership that this was something worth doing, everyone would agree it's worth doing, but was there a good business model associated with it? And so that took some time to do. As far as sheer numbers of people, it's less than 100, it's more than 10, and it just, we're looking at who is involved with circular economy within Veolia. So Veolia has a significant effort related to plastics. And plastics, you can label those as composites, although the plastics in a drinking water bottle are significantly different than the material used in a wind turbine blade. But we can leverage those expertise in those different offerings within Veolia. And in the plastics circular economy, we may have hundreds, if not thousands, of people that are involved in that globally in different geographies, because what works in Brazil may not work in Vietnam or Australia, but it works great in France. So every geography is uniquely different as it relates to a circular economy. And we've been very lucky, again, to be able to communicate those. So I'd love to say that you push a button and you've got 1,000 researchers all of a sudden trying to figure out the solution. That's not the way it works, but there are people that are ready to go to be able to provide effort and considerable intellect into coming up with some of these solutions. And they don't always work, that's for sure. You got to fail fast so that you can continue on to the next thing. And we failed fast in the wind turbine blades. We went after a more traditional recycling effort first. We looked at a pyrolysis technology. It's been around for a long time. It's a very relevant technology. But commercially and to scale, we couldn't make it work for what the industry wanted us to achieve. There's lots of things to do with wind turbine blades. They made in some pretty unique furniture. There's folks looking at using them perhaps as structural pieces in pedestrian bridges. There's all kinds of really neat things. But what we were looking for, what the industry and GE Renewables specifically was asking for, what could we do at scale? And so the use of this material in cement co-processing meets the scale requirement that's necessary to manage literally thousands and thousands of blades per year into the near future as it relates to repower. And I think one of the questions earlier was, what's the vision? Well, the vision is that this is a very long-term business plan. We're addressing the immediate need, but there's a considerable amount of material that is still going to need to be managed into the future, way past 10 years. And the wind turbine blade foundation, from a volume standpoint, allows us to look at other kind of niche wastes as it relates to the composites industry. The wind turbine blade composite, if you look at it in a pie from an overall volume standpoint, it's a relatively small piece of the pie. But if you look at composites in general, what other things are composites, the categories get quite large. So we're looking at other unique things. We're looking at how we might manage waste from the manufacturing of pleasure boats, because those are predominantly fiberglass. And those floats that purchase boats for personal use are typically pretty conscious about the environment. They're out in pristine waters and want to see it stay that way. So, there's a drive to do some other things with composites, and we've been working very closely with the American Composite Manufacturers Association and those folks. So hopefully this is just the tip of the iceberg. It's a pretty big visual iceberg as it relates to a wind turbine blade, but we hope to morph this into other offerings for the industry for circular economy.
Yeah, that makes a lot of sense. And the thing you said about scale, I think, like you said, that's one of the bottlenecks for sure, because we've seen, playgrounds over in Europe where there's, the shell of a winter blade. It's super cool, but, there's tens and going to be hundreds of thousands of these blades. We could all use more playgrounds, but that doesn't seem like a scalable solution. So, but concrete, there's so much development and the world's not going to stop. So that makes a lot of sense. So Chris, one thing I want to talk about is, this sounds like on the surface, like, oh, this makes perfect sense. Let's just shred all the blades, turn them into concrete. But there's still a lot of logistical headaches that go around with this. Like, it's not that easy because these blades are now over 100 meters long. So even if you wanted to shred the thing, that's not just like okay, we'll show up on your facility. So can you tell us about sort of all the logistical headaches and the bottlenecks and just how challenging it is to not only get this technology going, but just to even get the darn blades to your shredding facilities?
Well, first off, when people think of fiberglass, and maybe they think of something that's rather flimsy, or maybe they're thinking of a part on a car, or maybe the boat, for instance. But let me tell you, these wind turbine blades are pretty robust. Anything that's going to be around for 25 to 30 years with wind tip speeds approaching 200 miles an hour, they're pretty robust. So one of the first challenges is it's extremely hard to shred and manage this material. But to your first question, Dan, yes, these are rather large. Logistically, they're challenging. They can be in remote locations. So getting the material from where it's been generated or where it's at to a place where it can be processed is one of the main challenges. And again, Veolia has been very lucky. We manage the movements of lots of materials globally, especially in the US. So we're able to leverage that. And the very basic process flow is a blade is removed from the turbine. It is cut in the field into approximately 40 to 50 foot lengths. Those lengths are then put on a normal flatbed trailer truck so that there aren't any special permits associated with its movement. And then that material is directed to a location where there is a first shred of the material. And the reason why we're doing that as close as we can to the wind farm is because when we ship out of the wind farm, we are space limited. A blade weighs about 7 tons. You can get about 7 tons, one blade equivalent on a semi without any special permits. But you can ship 20 to 22 tons predominantly throughout the US as a normal size load. So we do the finished processing of the material in Louisiana, Missouri, and getting a wind turbine blade from Texas, let's say, to Missouri. We want to do a primary shred of that material in order to densify the material as much as possible. And then we're going to load that material into large end dump trucks and approach that 20-ton weight limit that I mentioned in order to minimize the cost associated with the transport and believe it or not, minimize the carbon footprint associated with transport. And that was one of the big things that GE Renewables did, was they hired an outside consultant to look at those types of things to ensure that we weren't doing more harm in the effort of doing good. And that all went into the equation. And there was quite a bit of thought and effort that went into that. It wasn't just let's do it. So there was a very keen interest in what the overall impact, positive or negative impact, that this would be to the environment. And it works out that it's still considerably positive for the environment. But the shipping logistics is very challenging, and it can be actually one of the biggest competitors to doing something beneficial with the blades, just because of the cost of transportation.
Yeah, that's such an interesting point, because I think Al and I were talking about on a different episode that I was reading, I can't remember what I was reading, but they were talking about the difference between grocery bags. So everyone thinks, yeah, just switch to paper grocery bags, they'll degrade in a rainstorm, better for the environment. But then when you start to think about the fact that a plastic bag is so lightweight, you can ship maybe like 10,000 in a truckload, maybe way more than that. But it was something like for every single-use plastic grocery bag, you had to use your paper bag because of the increased shipping weight, something like 6 or maybe 60 times to get the CO2 equivalent. And then if you had you bought a standard reusable grocery bag, you had to use that like 100 times. So those numbers are probably off, but just when you start to think of the weight of a paper grocery bag versus the plastic one, you see the CO2 is just like so different. So like you said, if you had to ship these blades across the country, it's burning up so much gasoline. It's just such a long journey where it might be a net negative for the environment. That's another one of those just huge challenges where people say, well, just recycle them. Well, it's just not that simple, is it?
No, it's not. And not only trucking, we've shipped blades via rail, and that's something we're looking at. And we even have the ability to accept material via barge if necessary. So each one of those has its own logistical challenges, and each one of them also has certain benefits. You can ship more material by rail with less CO2 than you can via truck. But you've got to be able to get it from point A to point B and those types of things. So they all go into the equation and into the management of the logistics associated with the repurposing of the materials.
And Alan, this is a question for you. I mean, do you ever see a day where an engineer is going to try to make the blade not only engineered for its life, like its service life, but also for end of life? Like, would you ever build some sort of like break point into a blade where you say, okay, when it reaches its 20 years, we can then take it apart more easily because of X, Y, and Z that we engineered into it? Is that a reasonable or unreasonable thing that an engineer might approach?
That day is here, really. And and I think as we start thinking about the end of life piece of it, which we really didn't do a lot of 20 years ago, and the engineers that are on staff today are thinking about that because it's a problem. Obviously, GE Renewables is thinking about it as the problem. And if you could sectionalize the blade, which GE has talked about for a long time, and make blinking the blade in sections, if it makes it easier to dispose of, in a way, to break it down, get it on a truck or a train and get it to a recycling center, and it saves a lot of CO2 in that process, sure, why not? I think there's a lot of reasons to do it and less reasons not to do it now, especially when you have, with Veolia and Chris's technology, when you have that on the table and all the engineers know it, they're going to access that. They're going to say, we need to have that plan end of life. And when the GEs of the world go to the planning boards that involve erecting wind turbines, that's going to be a major part of the presentation they're going to make is, hey, we're going to be able to take these things down when the end of life does happen, and we're going to be able to recycle them in a responsible way, and here's the steps we're going to take to do it. That is great from GE's perspective, it's great from the community's perspective, and it's great from Veolia's perspective that everybody wins in that conversation. So I definitely think we're headed there today, and I don't think we're ever going to go back. I think the recyclability and reuse is here to stay.
At the science of circular economy, to Alan's point, engineers are designing the end into the product at the beginning. And that was something we didn't really think about 20 years ago. But today we have to. We realize we're on this spaceship and there's a finite amount of materials and population growth continues, we are going to have to resource materials from things that we've already used before. And the whole science behind circular economy is embracing that. This material from the wind turbine blade might not become a wind turbine blade again, but if it can become something resourceful, then circular economy is being utilized.
And so what are some of the other challenges, Chris, as you guys try to get better at this, make it more efficient, more profitable, reduce carbon footprint, and increase recyclability? What's on your horizon to keep getting better at this?
Well, it's quite challenging to manage this material. It's a very robust, very strong. It's easier, in my opinion, to shred an engine block from a car than it is this material. And the equipment that we're using has not been built for purpose. We're talking to engineers who are thinking about what they can do to better their product to be able to supply Veolia with the equipment that makes us more efficient. But most of this equipment has come from the forestry industry. If you could imagine clearing a large sect of land for some purpose, what do you do with the trees or the brush or the materials from that? So the forestry industry has a number of different really unique products that can be used in order to reduce the size or shred material or chip material. So that's the first place that we went. But if you look at industry as a whole, Veolia, for instance, we manage a considerable amount of municipal solid waste. And in the management of that municipal solid waste, we have to do sorting and size minimization of that material. That all comes into play into what we're doing. So we are doing sorting of the material. There are some undesirable materials that we want to get out of the material before it is used in cement co-processing. And that technology specifically came from our knowledge in the municipal waste applications that we have. So what's the biggest impediment? Innovation is going to continue to occur. What we do today and tomorrow may not be the same thing we're doing 2 or 3 years from now. So we need to have a vision and visibility into other technologies and other innovations to continue to make this a productive resource management. That's always a challenge, is being on top of the innovation curve. And there's a lot of smart people. Unfortunately, they're not all in Veolia. And fortunately, those that aren't, we look at opportunities for collaboration. So we realize that. The hard part is going to continue to be, especially in this day and age, is getting access to really good talent that wants to participate and contribute to what we're doing. And that will always be a challenge. And so it faces all of industry, especially right now, post or during the end of this pandemic. That's a challenge. So again, for us, the challenge is to continue to make this commercially viable, be able to stay on top of technical innovation, and then perhaps leverage what we know and spread out to provide other opportunities throughout the U.S. and throughout the world. So one of the great things that Veolia does, what we're learning here from a knowledge transfer standpoint, we're transferring to other countries that are asking what to do with their end-of-life materials, especially in renewable energy.
I want to take a quick step back because I know we've got a lot of blade technicians that listen to this show and just a lot of blade nerds in general. And they're probably wondering, well, how do you recycle the lightning protection system inside, that down conductor cable? What about the root? There's all those bolts. Can you take us through some of the nuts and bolts of it, pun intended, how you handle some of the metal material in there, how you go through sorting because, there's more carbon fiber inside these blades than ever. And I assume they don't, they're going to have to get sorted and processed separately. So can you take us through some of the nitty gritty stuff that maybe our technician friends out there are interested in hearing?
Sure. So the first thing is an apology to those wind turbine blade engineers because they put a lot of time and effort into making a beautiful, robust piece of equipment, and we're destroying it. So kudos to them.
We need video. We need video, Chris. We got to get your media people to put these shredders, because I've watched engine blocks getting shredded on YouTube. It's fascinating. It's mesmerizing. I want to see a 300-foot blade get sucked into a wood chipper or whatever this contraption looks like and demolished, because that's a viral video.
I'd show you video, Dan, but then I'd have to kill you.
All right. Fine.
But no, you asked a great question. When we cut this blade up into sections, it's exposing different parts of it. That allows us to remove some of those undesirable materials by hand. Certainly as we're going through some of the shredding processes, there's the ability to remove some of that as well. When we get into the finished shredding of the material, this material is typically going to be 2-inch minus or less in size. We're actually using sorting technology, again, that came predominantly from the municipal solid waste industry, to identify chlorinated materials, specifically chlorinated foams that are in the blade, and remove that. To date, we're at, by weight, we're at about an 85 to 90% by weight repurposing and recycling of the materials. Wow. The roots are definitely the strongest part of the blade. We have a technology for that. We don't have it in place today, but we hope to have it in place by mid-year next year. And that will take us to a greater than 95% recycling of the entire blade, if not more. Some manufacturers use carbon fiber in their recipe for blade manufacturing. Some don't. The carbon fiber is undesirable for the kilns that are using this material. And again, we can optically sort that material out. Then the next step will be, how do we recycle the carbon fiber that we're able to remove? And we've already done some pilot testing on that as well. So again, it continues to evolve as we find innovative opportunities. And none of it's easy. And like I mentioned earlier, the equipment that we're using today is most likely not the equipment we'll be using next year or the years after. When you look at the offshore wind turbine blades, oh my God, they're huge.
Enormous. Yeah, so big.
Enormous. And even today, some of the initial equipment that we developed to cut the blade in the field, we were recently called out. A new wind farm was being constructed and a blade got damaged in transport. So they wanted to recycle that blade. And that blade was significantly larger than the blades that we're processing right now. And so we came back and we had to go to the drawing board in order to come up with some different technology in order to just address that blade that's present day onshore. Plus how we're going to do these large offshore blades 20 years from now when they reach their end of life. I'm looking forward to seeing how that's managed.
Well, and when you talk about, your researchers and your engineers and your people within Veolia, and you talk about how you've adapted a lot of forestry equipment into, these shredding, where are you going to develop like the next gen saws and shredders? I mean, is that anything you'll do in-house, or will you guys maybe acquire a company, or is it just partnerships? I mean, how does that look when you really might need a completely dedicated from the ground up shredder for these gigantic blades?
It's all of those things. It definitely, we're using in-house expertise. A lot of it is collaboration with partnerships. And they're not just vendors anymore. In order to be successful in business today, you've got to have real partnerships. Our contract with GE Renewables is a partnership. It's not a vendor-supplier relationship. It's a real partnership. And the same thing with the folks supplying us with technology. They're sitting around at a table with some of our folks, and we're spitballing ideas and coming up with different ideas on what to do. And then we're both, or all the parties, are going back to the drawing board in order to try to come up with some innovative ideas we'll try those ideas. Some will fail, some will succeed, and we'll continue to evolve the ones that succeed and learn from the ones that fail.
Chris, the issue with carbon fiber, I want to understand that a little bit further. One of my roles is as an engineer in designing airplanes, particularly carbon fiber airplanes. And the carbon fiber advent started about in the mid 1980s, and now some of those airplanes are coming to end of life, and there's a lot of them. And Boeing is not going to make many aluminum airplanes. They're going to be mostly carbon fiber, and so is Airbus and most other manufacturers. Even these little small electric airplanes we're talking about are all going to be carbon fiber of some sort. Is there a recycle path that Veolia is interested in or can be part of? And what is the difference between carbon fiber and fiberglass in terms of recyclability?
Great question, Alan. And the funny thing is on this, it being a small world, my first personal exposure into the pyrolysis technology was a challenge that came from Airbus to our colleagues in France on what to do with carbon fiber, predominantly from waste in the manufacturing of their current generation airplanes. And so that sent us down this pyrolysis path and looking at carbon fiber recycling. And so, you could actually say that the aircraft industry was part of what started us looking at some of these things. And it'll continue to be that way. So the carbon fiber is used in some of the manufacturing of wind turbine blades. Others don't use it. I don't know what the future holds, certainly as they're looking at different thermal sets and what they might use in the blades, and certainly as the blades get larger, what that might require. The carbon fiber, when you recycle it through any number of different processes, I can speak to pyrolysis because I had personal exposure to it. The carbon fiber maintains a great deal of its inherent properties of strength and low weight, even when it's been through one of these thermal processes. It may retain greater than 90 or 95% of its properties. So you could use that back in some production of a piece, potentially of an aircraft. Maybe it's not a structural piece, but maybe it's a lightweight cover of some sort, engine shroud. I don't know how the engineers decide, but when you look at the fiberglass material, the fiberglass through that type of thermal recycling processes loses a great deal of its inherent good properties. And the cost of carbon fiber also motivates a commercial opportunity that is much more cost effective than it is for fiberglass. So they're just different materials. They're both composites. They're just different materials and how they get managed. But Veolia is definitely looking at that and looking at any number of traditional, what we think of recycling. Aluminum can becomes an aluminum can again. And we're bridging different industries. So you look at the food and beverage industry, it's trying to figure out what to do with a yogurt container. And we're bridging a conversation then with a large chemical processing industry to say, look, if we collected this material, sized it in such a way, could you somehow use it as a raw material to make another monomer or a polymer in your process? And the answer is a very strong maybe, and in some cases it's a definite yes. So now how do you get the food and beverage industry talking to large energy or chemical processing industry? And that's where Veolia helps manifest that collaboration between the two industries.
That's a really good segue into my final question, which is this, so you have a partnership obviously with GE, but can any wind farm take advantage of your shredding? I mean, how do we get more of these blades that are decommissioned or just sitting around, into your shredding facility and turned into concrete?
Sure. So we are not exclusive to GE Renewables. And to be quite honest with you, I think GE Renewables wanted that so that we would have an opportunity to provide a resource to the rest of the renewable energy, the wind industry in particular. So there's nothing that prevents any of the other OEMs or any owners from other wind farms from accessing Veolia and the offering that we have. I would say the industry's been waiting for a solution. Veolia is one of those solutions that is available now to the industry. There have been some startups in the past that have not been so successful in trying to recycle or repurpose blades. So we had to overcome a little bit of that negative momentum associated with that. And we also wanted to make sure that we could crawl, walk, and run before we really got ahead of ourselves. So the last year or so has been just that. We've been learning what to do, refining the processes that we have, and we're ready now to address the larger market with a sustainable solution, both commercially and environmentally. So there's nothing preventing anyone from utilizing our services. To be quite honest with you, the industry knows that we're available. We're not currently doing very active business development just because the phone is somewhat ringing off the hook, if you will, with folks making inquiries on what Veolia might be able to offer.
Okay, so it sounds like then you guys are ready to take blades from wind farms all over the U.S. So hopefully there's someone listening to the show today, and that's part of the reason we want to have you on, is because it's such an important thing for the environment to get these blades where they need to go. So it sounds like they can just reach out to you and start the process.
You're exactly right, Dan. We can't be all things to all people, and we'll be the first to say that we can't, but we are trying to be as much of a resource as we can to any of the projects that are out there. We've got to be careful that we don't overstep our capacity capabilities, but yes, we're open for business and ready to help find solutions for folks in the wind turbine industry for end-of-life wind turbine blades.
Well, awesome. Well, Chris, we're so appreciative that you were able to come and sit down with us today. How can people follow up with Veolia and the work that you're doing?
Sure. You know, the web is certainly the best place, Veolia.com. And then for us, VeoliaNorthAmerica.com. You can look in our news portion, follow up with what we've been doing with GE Renewables as we have other contracts that we can be newsworthy, that we can articulate to the market. We will. But certainly VeoliaNorthAmerica.com is a great place to start, and you can make an inquiry there. And I see nearly all of those inquiries that come through the website.
Thanks again from both of us, Chris. We're really appreciative, and we're really thankful for the work in general that the environment needs. I mean, you guys are doing great work and at scale, really making an impact on the planet. So thanks so much for coming on the show and for the work that you're doing.
Well, thanks, Dan Allen, for having me. Really appreciate it. Thanks.
All right. Well, that's going to wrap up our episode of the Uptime Wind Energy Podcast. Thanks again to the team at Veolia for getting us set up with Chris Howell, who again is the Senior Director of Recycling Operations at Veolia, and they're doing some pretty amazing things. So be sure to check out the description or show notes of this podcast, whether you're listening on YouTube, iTunes, Spotify, Stitcher, and follow up with Veolia. And, this is, like I said, this is exciting stuff that the wind industry really needs. So we're really thankful for having them on the show. Thanks again. And from Alan and Rosemary and myself, we will see you here next week on the Uptime Podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.